How's going on everyone? Welcome back to our algorithm design and analysis series. Today, in this video, we are going to discuss the algorithm of bubble sort. In bubble sort, we iterate over each element of the array until the array is sorted. Each time we iterate over an element, we check that if that element is greater than its successor. If yes, then we swap both of the elements. Each time when we iterate over the array, the largest number in the array is sorted at the last position. Let us see how bubble sort works. Consider this sequence. We will iterate over the whole array for the first time. We call it pass 1. So our first element is 44. 44 is greater than its successor, that is 23. Therefore, we swap 44 and 23. In next step, we move to a second element, that is 44. Again, 44 is greater than its successor, that is 11. So again we swap 44 and 11. In next step, we move to a third element, that is again 44. Now 44 is smaller than its successor, that is 86. So we do nothing and we move to fourth element. Fourth element is 86. 86 is greater than 69. So we swap 86 and 69. In next step, we move to fifth element. Fifth element is again 86. 86 is greater than its successor, that is 5. So again we swap 86 and 5. In our next step, we move to sixth element, that is 86. 86 is again greater than 72. So we will swap 86 and 72. This ends our first pass. In this we can see that the largest number in the whole array, that is 86, is sorted at the last position. In first pass, we checked n-1 elements of the array. But we can see that as the last element is already sorted, therefore we have to check only n-2 elements, that is 5 elements of the array. So we start comparing the elements of the array from beginning again. This starts a pass 2. In pass 2, first element is 23. 23 is greater than its successor, that is 11. So we swap 23 and 11. Next we move to step 2. In step 2, we check our second element, that is again 23. 23 is smaller than 44. So we do nothing and move to third element in step 3. Third element is 44. 44 is again smaller than 69. Therefore, we move to step 4. In step 4, we check our fourth element. Fourth element is 69 and it is greater than its successor, that is 5. So we swap 69 and 5. Next we move to step 5. In step 5, we check our fifth element, that is 69. 69 is smaller than 72, so we do nothing and this ends up pass 2. We can see that the largest element in this subarray, that is 72, is also sorted at its last position. Therefore, in our next pass, we will check only the first 4 elements of the array. We would sort the remaining array in the similar manner and finally our sequence would look like this. This is the sorted sequence. We saw that in each pass, we iterated over n-i elements of the array. Because every time we iterate over the array, the largest element in the array is sorted at the last position and we do not have to check it again. Here, I denotes the number of pass and n denotes the size of sequence. Now let us see the algorithm of bubble sort. First, we have a for loop which starts at index I equal to 0 and increments up to n-2. This for loop runs n times and it is used to iterate over the whole array n-1 times. Next we have a declaration statement. Let us ignore this statement for once, we will come back to it later. Next we have a for loop which starts at index j equals to 0 and increments up to n-i-1. This for loop is used to iterate over each element of the array. This for loop runs n+1 by 2 times. Next we have a conditional statement that checks that if the jth element of the array is greater than its successor. If it is greater than its successor, both of the elements are swapped. This was a simple algorithm of bubble sort, but there is one problem with this algorithm. Consider an array which was already sorted. We don't need to sort that array, but if we pass that array into this algorithm, first for loop will iterate over the whole array n-1 times and next for loop will check if each of the element is greater than its successor or not. Therefore, it would run for unnecessarily long time and our time would be wasted. So we optimized our algorithm such that if it gets sorted before n-1 iterations, it gets automatically stopped. We initialized a boolean variable swapped initially as false. If we swap any number in a particular iteration, we change swapped to true. Now, after iterating over each row, we check that if the swapped is false or not. If swapped is false, that means there was no swapping of number, which means that the array was sorted. Therefore, we break a for loop. Hence, we need not to run our algorithm even when the sequence is sorted. We can see that the highest degree of n in the whole algorithm is 2. Therefore, the time complexity of this algorithm is theta of n square. Now let us discuss the best and the worst case for bubble sort. We have already discussed that if our array is already sorted, we need not to run a for loop n-1 times. Therefore, if our array is already sorted, for loop will run only once and compare each element, and it will automatically break as there is no swapping. Therefore, the best case for bubble sort is when array is already sorted. The time complexity in such case is given by theta of n because a for loop runs only n times. Now consider another array which is in decreasing order. In such case, the algorithm has to sort each and every element of the array. Therefore, the worst case is when the sequence is reverse sorted or is in decreasing order. The time complexity of worst case is given by theta of n square. This is a simple C++ program implementing the algorithm of bubble sort. Let the size of the sequence be 10. Let us enter the sequence. Hence, we get a sorted sequence using bubble sort. This program is available in both C and C++ language on our GitHub profile. Link is given in the description box. That's all for this video. Thank you for watching this video. If you like this video, please give it a thumbs up and subscribe our channel for similar content. If you have any doubts or suggestions for us, please share with us in the comment section. You can also contact us through our Instagram and Twitter profile. Link is given in the description box.